Actually, most of the world's canyons and most of the river valleys are what you call underfit streams. Geologically, that means that the present river is not capable of carving that big canyon. So we have to think about lots more water instead of lots more time. Dury, who works a lot with landforms and stream erosion, says that most of the world's river valleys are what are called underfit streams. So how do we explain them? Well, think about it. The mountain's rising up. The valley's sinking down. Now, first of all, you have a lot more water going down through there, don't you? You have saturated sediment. Again, even the rivers that are there are going to be greatly enhanced with more water. So the erosion will also be enhanced. But as you raise up a mountain coming up out of the sea, what else do you raise up with the mountains or bring up with the mountains? Huge inland lakes, right? Big ones. Now, as this stuff is in motion like this, it's just rising up. Eventually, that water will all of a sudden collapse and go right down those little channels, eroding them out. That's what we would expect to see. Well, you know, we'd also have, as you raise up land masses, you'd have river drainages being blocked by these land masses. And pretty soon, the water would start backing up behind those things. And it would back up and back up and back up and back up until what? Finally, it's so much water, it overtops that natural dam. And anybody who's worked with overtop reservoirs knows that can make for a catastrophic situation downstream. Because dams don't fail slowly. They go catastrophically, and you have all that water going downstreams. You know, there's a spot over here at Salt Lake City. You can look on the sides of the mountains up there, 1,000 feet above the present Salt Lake, and you see ridges and benches. What are those benches from? An ancient inland sea. Today, the Great Salt Lake is a tiny remnant of what's called the ancient Lake Bonneville. And you can follow that shoreline for about 250 miles. That would have held water of 22,500 square miles. That's a lot of water backed up, isn't it? They now think that that catastrophically drained right down through Red Rock Pass in Idaho, and when that did, it would have formed a huge canyon below. You know what's below that? Snake River Canyon. And goes right on down into the Columbia and out to Portland. Big canyon, big lake up above. You go to the Dry Falls, which is in Washington near Coulee City, and there you find even a signpost saying there used to be a giant waterfall in this area. Now this is from a different lake. This is not from Lake Bonneville. This is from what's called the ancient Lake Missoula. And when you look at shorelines, the ancient Lake Missoula, you look above Missoula, Montana, and there they are, 900 feet above Missoula. They now realize something backed up the water until there was 500 cubic miles this time, of water impounded. And they think it might have been a glacial ice dam. And then it finally broke, and all 500 cubic miles went downstream catastrophically. When it did, there's a huge waterfall coming out here, and it carved a canyon, according to secular geologists, that's 22 miles long, 6 miles wide, and 400 to 900 feet deep. And how long did it take to do it? Days. Or several episodes of a few days, if it happened that the ice dam formed again. But what we're looking at is it doesn't take a lot of time to form something like that, does it? Time's not the hero of the plot.